Hello? Hello? Hello, good afternoon. Good evening, everybody. Today, I would like to learn about the Kage courses. We already know that there are various useful courses in Kaggle, like Python programming, introduction to machine learning, and also about the useful library and framework related with the machine learning. Mm, uh, and we are currently learning. In the previous week, we have learned about the Python programming and introduction to programming. But in our group, there are most of the people are already get insight with the knowledge with introduction to programming. So this week, we aim to learn about the introduction to machine learning. And here, we can learn the core ideas in machine learning, and we can build our models using the Python programming language. Because when we learn about the machine learning, we can use different programming languages, for example, Python, or if we would like to focus on the data science, then a programming language, or sometimes we can also use the C programming language. Yes, so there are various programming languages in learning the machine learning. However, here in this course, we have to learn machine learning by using the Python programming language. And let's check this course. And here we can learn about the core ideas in machine learning, and we can build our model, our very fast model. This is the beginner course for which will take about 3 hours, and it based on Python. And it is this course is about the preparation for machine learning, explain ability, intermediate machine learning, and this is also the way to deep learning. And there is no extra courses like other KG courses. And thanks to our instructor for this learning course. And like other KG courses, there are tutorial and each corresponding exercise to test for our to test in what we learn in our tutorial part. And now here, let's check. There are about 5, 6, 7 parts in this course, and the first one is how models work. With here, let's in the part 1 of the lesson, there is only tutorial, as we can see. We can clearly see here, and no corresponding exercise, and the exercise will start from part 2. So if by checking the lesson title here, we can know that there is how machine learning models work. And that in the part 2 about the basic data exploration. We are about to learn the machine learning, but here the title is about the basic data exploration, because machine learning models are to mine, to explore about the richest knowledge from data, because as we already know, we use data in various ways every day, every hour, every minute, every second. And so from this tremendous data, we would like to explore about the richest knowledge, and so we use the machine learning model. So the part 2 is about the basic data exploration. We can learn and understand about our data. If we don't understand clearly about the data, and then there is no matter how we use the how effective machine learning algorithm. Before we use the machine learning algorithm, we would like to get insight into our nature of our data that we need to handle. If we understand about the data very well, then we can handle it and we can get knowledge from this data by using machine learning model. And then in part 3, this is our first machine learning model. We can build our very first machine learning model. Yes, it is very cool. In part 4, part 4 is about model validation. To measure the performance of our model, because we are just learning about the data that we would like to mine, we would like to get insight, and then we use machine learning and specific machine learning model, and it is not finished. We need to validate our model. Yes, we need to measure the performance of our model, so we can test and compare alternatively. And another part 5 is about underfitting and overfitting. Yes, we need to fine-tune our model to get better performance. We are using machine learning model to focus by focusing our data to mine the knowledge about data. We use machine learning model. Then we expect to get the high performance, and just understanding about the data and using the machine learning model, it is not enough until now. We need to fine-tune our model to get better performance. Yes, in part 5, we can understand about underfitting and overfitting, which are very important important theory in to get better performance in machine learning. And then in part 6, we can use a more sophisticated machine learning algorithm by using the well-known random forest algorithm. Then in part 7, this is the last one. In the final part, we can enter the world of machine learning computations, and we can keep improving and seeing our progress more in real-world computation. Anyway, let's get started from the part 1. Part 1 is how the model works. Yes, this is the first step if someone is new to machine learning. Here, introduction. Let's check, is this too much text or not? No, not too much text. Okay, let's read this paragraph. We will start with an overview of how machine learning models work and how they are used. Yes, now we are about to start how machine learning models work and how they are used. And this may seem basic if you have done statistical modeling or machine learning before. If someone is the one who already know about machine learning and who already have the experience of doing statistical modeling or machine learning before this lesson, then he or she may feel like, oh, this is just very basic. So, but don't worry, we will progress to building powerful models soon. Yes, this is just for the this is just for the overview. So don't worry, we will progress powerful models soon. And this goal will help you build models as you go through following scenario. Because our what we done using the computer science, yes, and this we are just based on the real world scenarios. So just think about the real world scenario. Here it is given as in the following sentence. Okay, let's read it. Your cousin has made millions of dollars speculating on real estate. He's offered to become business partners with you because of your interest in data science. He will supply the money and you will supply models that predict how much various houses are worth. You ask your cousin how he has predicted real estate values in the past, and he says it is just intuition. Yes, he said it is he just predicted about his real estate values in the past and by using just his intuition, normal intuition. There is no systematic uh, calculation, computation, or there is no statistical. There is no how can I say? He just predicted his real estate values by just his normal intuition. There is no statistical model or there is no uh, systematic computation. But more questioning reveals that he is identifying price pattern from houses he has seen in the past. And he used those patterns to make predictions for new houses he is considering. Machine learning works for the same way. Yes, we will start with a model called the decision tree. Okay, let's think about the example. This example is you have a cousin and your cousin is making his job, his work is about making millions of dollars speculating on real estate. And now he is offering to become business partner with you. The reason is your interest in data science. And he said he will supply the money to you and you have to supply the models, machine learning models to him to predict how much various houses are worth. I think you may understand this scenario. And so now you have question. Okay, I will start to predict about your houses about about dollars on your real estate. But I would like to ask you a question. So how did you usually predict your real estate values in the past? In the past mean you before you asked to me to predict for your work by using machine learning model, and in the past how did you do? And your cousin say it is just intuition. Wow, it's just intuition. but more questioning reveals that he is identifying price pattern. Yes, your cousin is identifying the price pattern from houses he has seen in the past because his job is on predicting about real estate values. Yes, his job is um, speculating on real estate, and so he need to predict real estate values for different houses, and he predict using the houses using the price pattern for houses he has seen in the past, and he used those pattern. Yes, here is the keyword is the pattern. He used a pattern to make prediction for new houses. The pattern from previous houses or the pattern from houses in the past he has seen in the past, and he predict by using those patterns for new houses. Yes, Yes, machine learning also works in the same way because we will start a model where we can use a model, machine learning model, that's anyway decision tree or random forest or uh, Bayesian naive Bayes or Bayesian algorithm or any machine learning algorithm. No matter which problem it is, but anyway, we need to predict. If we would like to predict for the new data, then we need the best data, the best, the similar data in the past. Then we can start a model. But in this example, we will start a model using called the decision tree. And there are also fancier models that give more accurate prediction. Yes, there are different machine learning models. But here, we use decision tree because decision trees are easy to understand and they are the basic building blocks for some of the best models in data science. For simplicity, we will start with the simplest possible decision tree. Yes, because this is our very first example. So we will start with the simplest possible decision tree machine learning algorithm. For example, here, according to the name, it is to make decision, like by using the tree structure. Yes, it's very meaningful. The name, what just we looking looking at the title, the name of the model, then we can understand. We can get insight about how model was generally, because this is we have to make the decision by using the tree structure. Here we can see this image. This picture is like the tree structure that we usually use in data structure and analysis of algorithm that we have already learned in our computer science journey. Yes, for example, this house have more than 2 bedrooms. It means that it's just like when we want to hire, or if we would like to buy a house, then we would like to know this just simple normal question. Is there any more than 2 bedrooms in the house? Then yes. If the answer is yes, the predicted price is about around this US dollar. Or if the answer is no, the predicted price is also different. Yes, it divides houses into only two categories. Oh, yes, only two categories. And the predicted price for any house. And the consideration is the historic average price of houses in the same category. We use data to decide how to break the houses into two groups. Yes, it's very simple. We have data and we use that data. And we use this data to decide how to break the houses into two groups, just into two groups. And then again to determine the predicted price in each group. This step is of capturing patterns from data is called fitting or training the model. The data used to fit the model is called the training data. In this paragraph, we need to memorize about some acronym used in machine learning. For example, like fitting the model or training the model, or and also about the training data. For example, we have the data and we partition the data into 2 parts or 3 parts, and then the first part is to use to fit the model. Then we can call the data the training data. And the details of how the model is fit, for example, how to separate the data, is a bit complex, and that we will understand. We will learn it later. So after the model has been fit or after the model has been trained, you can apply it to the new data to predict prices of additional houses, additional homes. So if we would like to improve the decision tree, because the decision tree is very simple, as we can see here, we use the data and there is only two answer, yes or no, two condition. Which of the following two decision tree is more likely to result from fitting the real estate training data? Okay, let's check. There is first decision tree and the second decision tree. The question is the same. Does house have more than two bedrooms? From the left figure, and from the right picture is also the same. Does house has more than two bedrooms? If yes, but the difference is in the left picture, if in the yes condition, the predicted price is more than in the no condition case, and in the second decision tree on the right side, if the house has more than two bedrooms, then if we choose yes, the predicted price is lower than if we didn't choose it no case. So which is more natural, which has more naturalness with the real world case? So the decision tree on the left, decision tree one probably makes more sense. Yes, is for example, decision tree is make more sense with the real world case because it captures the reality that houses with more bedroom tend to sell at higher prices than houses with fewer bedroom. And the biggest shortcoming of this model means the decision tree model, is that it doesn't capture most factors affecting home price like number of bedroom, lot size, location, etc. Because in real world case, we usually consider, if we would like to buy a house, we usually consider more than the bedroom number of bedroom. We also think about number of bedroom, lot size, location, etc. You can capture more factors using a tree. So we can have a question. So how should we do? How should our model do to consider for the other factors, other features, or other other factor? Then you can capture more factor using the decision tree has just to split it more and more. These are called debug tree. Yes, the tree began to debug. For example, here only there are only two steps. Then here the trees began deeper because we use more split. As a decision tree that also consider the total size of each house lot might look like this tree. For example, firstly, we consider or we ask to the real estate company. I'm interested about buying the house and I would like to know and I see the picture of I choose the picture of the house, and then I have a question to you. Does the house have more than two bedroom? And the real estate company reply you yes, and you ask more question. For example, the lot size larger than 1,100. 11,500 square feet, and he may reply you like yes or no. For example, if yes, then the predicted price is more and more. Yes, these are more. This decision tree makes more sense to you with the real world case. So you predict the price of any house by tracing through the decision tree, always picking the bets corresponding to that house characteristic. The predicted price for the house is at the bottom of the tree. So we would like to know, what we would like to know is just the price, just the predicted price. And if we look at this decision tree, is it a deeper tree or is it a very shallow tree? No matter it is, we can know about the predicted price by using the lowest bottom of the tree, which is also called the leaf, LEA, have lived in computer science dams. Yes, and the space and values of all the lists will be determined by the data. Yes, and we are just using the decision tree, but it will the decision tree predicting the values using the machine learning model also can have different with each other based on the data. So it is time now. It is time for you, for me to check out the data we will be working with. Okay, let's continue to get more specific. Just clicking the start tutorial. Okay, this is step 2 of the course. Using pandas to get familiar with your data. Now we have we need to understand more keyword. This is PANDS pandas. What is a pandas? You may already familiar with this word or not. That's no problem. If it is the new word for you, then this panda is the name of the machine learning library. If we would like to handle the data in data science, we need to understand about the framework or different framework that are commonly used in machine learning models. Yes, now the first step in any machine learning project is to familiarize yourself with the data. Yes, because you may think that this is a machine learning project, so the machine learning algorithm must be the most important. Yes, it's true to some extent, but we use machine learning model. We are performing some machine learning project because we would like to we would like to get insight into the data. So it is very important. The first step in any machine learning model is to familiarize yourself with the data before doing any machine learning steps. You will use the pandas library for this. So here you can use the pandas library. And panda is the primary tool data scientists use for exploring and manipulating data. So what is pandas? Pandas is the library, the primary tool that data scientists use for exploring and manipulating data. And most people abbreviate pandas in their code as PD. For example, like import pandas as PD. So we do this with this following command. The most important part of the pandas library is the data frame. So firstly, we are learning about the machine learning and now we are about to explore the data. So we are using the primary tool for data scientists, and this is the name is pandas. So now we are learning about the pandas library. So the most important part of the pandas library is the data frame. A data frame holds the types of data you might think of as a table. So data frame in the data frame, they hold the type of data, different type of data you might think of as a table that you usually see in the Excel file. And this is similar to a sheet in Excel. Yes, here is also written like that. This is similar to a sheet in Excel or a table in SQL database or Microsoft Access or something like that. Pandas has powerful methods for most things you will want to do with this type of data. As an example, we will look at data about home prices in Melbourne, Australia. Now we are we are about to use the real-world data set. This data set consists of the data about home prices in Melbourne, Australia. And in the hands-on exercise, you will apply the same process to a new data set because in the exercise, we need to use a new data set, not the same data set in this learning part. Yes, which has home prices in lower. Okay, anyway, no problem. Though the data set, the data are different, the structure are the same, hopefully. The example Melbourne data is at the find path in both. Here, this is our data set find path. We load and explore the data with the following comment. Then we need to load our data by using the comments like using the comments in the general programming language. For example, if we would like to save find path to variable for easier access, then this Melbourne find path, this is just giving the name, but we need to give the name using the naming convention like in the programming language, and then our name should be the meaningful one, so that if we share our model with other, for example, like group, and then other people will easily to understand. Or even if you are just checking your programming or your machine learning model later, because it has been specific time. After a specific time, you may forget or not. It's not sure. So just giving the meaningful name to variable is also important, like in general programming language. And then this is giving the name and then save the find path to variable for easier access. And then read the data and store data in data frame. Using, for example, because we are using the pandas and we import pandas as PD. So we use the name only this PD. No need to use the long name PNDS pandas. So just using PD, and then just we would like to call the function, so we need to use the dot sample. And then we are about to read the CSV file, so it's very simple. Read CSV, then we can read this CSV file, this .csv file. After reading the CSV file, we can print a summary of the data by using, for example, like this variable and dot sample to call the function, and the function name to print a summary of the data is DESCIMB describe. Then it will display you like this table in the Excel file, but this is the one which is by using which we call by using the pandas. And interpreting data description. For example, the above result show count means SGD mean 1, 2, 3, 4, 5, 6, 7, 8. Only 8 numbers for each column in your own dataset. The first number, the count, show how many rows have none missing value. So missing values arises for many reasons. For example, the size of the second bedroom wouldn't have collected. For example, let's see the second bedroom. Rooms are PET. Bedroom is here, bedroom 2. Rooms. The second bedroom. The size of the second bedroom. For example, in this bedroom column, here is the count and also the mean, standard deviation, mean, for example, like is percentage, and for example, there is this paragraph means that, for example, we can in our data we can encounter some kinds of missing or values, or some row has name missing values. So there may be name missing values or missing values. So you may would like to know why such kind of missing values include in our data, because there may be some certain reason. For example, if the data have not been collected when surveying about that, when surveying about, for example, now this is a house, right? So we will come back to the topic of missing data. It means we will focus on studying about the topic of missing data later in this course. And then the second value is the mean. Here the second value is the mean, which is the average. Yes, the mean means that it is the average value. We already know that. And under the mean group, the STD is the standard deviation. Here, STD is the standard deviation, which measure how numerically separate out the values are. If you not familiar with the mean as STD, you can search at the Google later. But now we will okay. Our session will finish soon. So see you in the next week. Bye bye.